I'm Kjaegaard, Professor of Evolutionary Study at Old University. Ever since the publication of Charles Darwin's two books, On the Origin of Species in 1859 and Descent of Man in 1871, we've been trying to get the human story right on a scientific basis. So we've been trying to use science as a way of understanding the question of where do we come from, who are we, what is our origin, and making sense of that. But that, of course, begs the question, what does it mean to understand something scientifically? And what we've seen over the past 150 years is that our explanations have changed. We've been basing the theories that we have, we've been basing the explanations that we have on a number of evidence from a number of different fields. That's fossil evidence, which started in the 19th century, including the first Neanderthal fossil remains that was found in 1856 in Europe. Later on in the 1890s, we found fossil evidence in Asia, and then from the 1920s onwards, we've been finding fossil evidence of early humans in Africa. So gradually, we've been finding evidence from early humans all over the world. So that's one part of the evidence that we've been collecting. We've also been collecting archaeological evidence and putting all that together and including genetic evidence over the past 10, 20 years has increased our understanding immensely, but it's also changed our understanding, and it's changed the explanations that we've had. Certain fossils have been interpreted in a specific way, and we've seen certain fossils to have a specific place in our own family tree, and these places, they have changed over time. It's important to know that this is just how science works. To give an example from physics, how these things changes, and how we know a lot about one thing, and then realizing that that was not what we actually thought, that can actually be quite helpful. In the 18th century, people knew a lot about something called caloric, which was heat stuff, and that was used to explain everything related to heat. That was the basis of the theory of heat. Eventually, people found out that there was no such thing as caloric, but that did not mean that all the things, all the experiments, and all the knowledge that we had about caloric, all the theories that was built around caloric, that they were worthless, and it came to nothing. That formed the basis of thermodynamics. In the 19th century, we have an equal story with the ether. Ether was the basis of the electromagnetic theory of light. We know now that there was no such thing as the ether, but it formed the basis of what we know about electromagnetism and light, which forms the basis of the electronic era that we're living in today, with everything from mobile phones to the internet to television, etc. Same thing about human evolutionary studies. We thought we knew a lot about different fossils or different archaeological artifacts, but we know that we were wrong. Doesn't mean that we have to discard everything. That just means scientific progress, and we're actually getting better at what we are doing. So that's very important to understand that this is an intrinsic character of scientific research. We find new things, we discover new things, we're able to get more precise dating. We find new evidence from genetic data, for instance. We find new fossils. That means that we have to revise certain bits of this and that, which means that science as storytelling, or science as human evolutionary studies as storytelling is important, but what is equally important and how scientific research actually works is also by science, by story testing. So this is a process that's going on continuously, and meaning that there are lots of things that we thought we knew, and we thought we knew with great certainty, but that has changed, and we now see things differently. But we are standing on a firmer ground all the time. We're gathering more evidence. We're gathering from a number of different fields, and this is one of the powers of the Darwinian explanation. One of the powers of what's made of the Origin of Species such a good book and such a successful. The power of converging evidence. Power of converging evidence from a lot of different fields coming together in one explanatory framework. And this is where we are at in human evolutionary studies today, that we have a number of different fields who are all contributing with their data, with their explanations, and forming a new synthesis of our understanding of human evolution. This is something that we should be prepared to, that this synthesis we have today, the big picture of what really happens in human evolution, that this will change. This is not something we should worry about. This is actually something we should cherish, because this is how science works. This is how we are going to get to know more about the world that we live in. And ultimately, in this case, this is what will eventually get us to know more about